What up, mathletes? Welcome back to another episode of Math with Dr. Math. And today we're going to talk about implicit differentiation. All right, so let's talk about this type of differentiation that might be a little bit confusing. All right, so before we do that, let's kind of take a step backwards. All right, when we're finding the derivative of a function, right, usually what we're accustomed to is we're usually having the function as f of x or g of x or y equals, and everything else on the other side of the equal sign has a bunch of x's, or it has x as the only variable, right? And so let's take a look at this problem down here. Right now we see this equation is not solved for y. So what we might want to do, and what we've done in the past, is we've taken the derivative of this with respect to x. But before that, right, y was already solved for. So in the past, let's rewrite this. In the past, what you're used to, all right, let's go ahead and solve for y. Subtract 8x from both sides. And you're left with 7y equals negative 8x plus 2. Then we'll divide by 7, divide by 7, divide by 7. So you're left with y equals negative 8/7 x plus 2/7. All right, so in the past what you were given is you were given some function, right, of x. And all that means is that you have this function here, this equation y equals, and on one side you have your x's and the other side you have your y's, right? And so what you were asked to do in the past is take the derivative of this, right, to find dy dx. And that was no problem, right? You could take the derivative of this, and so let's take the derivative of this. Let's derive this, so we're left with negative 8/7. And here we're left with the constant, so that goes away. So this was our derivative. But what we're going to start to see is this is a linear function, right? So this is kind of easy. A lot of these functions are going to grow, and at times it's going to be impossible once we solve for y to actually derive this, or it might be very difficult. All right, so this is why we need to understand how to use this tool of implicit differentiation. All right, this is going to be a very helpful tool. All right, so let's take a look at what does this actually look like. So let me move all this to the side here. All right, so let's see, what does this look like? All right, so what's nice about implicit differentiation, right, I'm going to look at part A here, is we don't have to do any solving. We could just jump in the game as is. And what the process tells us is right away what we're going to do is take the derivative of both sides with respect to x. So we're going to take the derivative of both sides with respect to x. All right, and notice here we have y, and y, remember what y represents. We just talked about it up here. Usually y is some equation that's equal to, and over here on the other side it has some x values. It could be x cubed, x squared, a whole bunch of things could be happening. But the point is it's going to be y equals something over here that has an x. I'm just throwing this as an example, right? This problem right here has nothing to do with this one. I just want to show you the fact that on one side you're going to have y, and on the other side you're going to have x's. So whenever you see a y, just know in your head, think about it in your head, that represents an equation that has the variable x on, right, on the other side there. So let's go ahead and take the derivative of this. All right. So when we take the derivative, we're going to take the derivative of every single piece here. So we take the derivative of 8x with respect to x, right? We're going to take the derivative of 7y with respect to x. And then we're going to take the derivative of this constant. But we already know the derivative of a constant. That's just 0. So that's going to equal 0. All right, so let's go ahead and do this. So here, when we take the derivative of 8x, well, we just get 8. So let's write that down. So this just becomes 8. And here we have 7, right? Whenever you have a constant, we could pull that constant to the front. All right. So plus, right, we have our properties of derivatives. So that constant, you can move it to the front. And now notice we're taking the derivative of y. So we could just call that y prime or dy dx, right? Remember, y prime is the same thing as writing dy dx. Those two things are exactly the same, just so you get familiar with it. All right? So when I take the derivative of y, I just get the derivative of y, whatever that is. I don't know what the equation y equals, right? I haven't solved for it, so I don't know what it is.
I don't know. What do you mean you don't know? I don't know.
So that's why I just write, well, whatever that equation is, I'm going to take the derivative of it. And that's how we represent that. And of course, that equals 0. And the whole goal, right, our goal is to find dy dx, which is this right here. Our goal is to actually solve for this. That's what we're after. All right. In the last problem that we did, that I give you an example, that's what we did. We got dy dx by itself. And we saw it was negative 8 over 7. So over here, we're hoping to get the same thing. All right, so let's take a look at that. Oh. So let's solve for, right, we're going to solve for y prime, which is just dy dx. So let's go ahead and subtract 8 from both sides. So we end up with 7y prime equals negative 8. All right, let me copy that over here, right here. And then now we just divide by 7. So divide both sides by 7. Divide by 7, divide by 7. So now what we've done is we have found dy dx. Right? This is dy dx. That's what y prime means. And what do you see? It's exactly the same thing we got over here. So right here, we're introducing you to other ways of taking the derivative, right? So this right here is called implicit differentiation. And we could use it whenever the y is not isolated, right? Whenever they give us the equation and the x and the y are on the same side of the equation. And we're going to find this to be very useful as we move forward. But this is the big idea. Alrighty? So hopefully that helps out. If you have questions, let me know. Comment below.